In this video, we're going to discuss a different form of lines called point-slope form that's really useful for helping to actually write lines. So point-slope form looks like this. Y minus y1 equals m times x minus x1. And what you actually get from point-slope form is you get a point with the coordinates x1, comma y1, and you get the slope, which again is going to be whatever m is. So we're getting two pieces of information, a point, x1, y1, and a slope m. So here we have this equation, y minus 4 equals 2 over 3, x plus 1. The slope, that part's actually pretty easy to identify. It's this 2 over 3. Now, the point is going to be the coordinates x1, comma y1. If you look at our form, y1 would be 4. So y1 is 4. The y coordinate is 4. However, you see this plus 1? That actually comes from a minus negative 1. So in this case, the x1 coordinate would be negative 1 because it was x plus 1, which is the same thing as minus negative 1. So if you had this equation here, the slope would be 2 over 3, and the coordinates of the point would be negative 1, comma 4. So if we have a negative coordinate, it'll actually go in as a plus. We're going to use point-slope form now to help us write some different lines. We're going to write the equation of the line that has the given point and slope in the form ax plus by equals c with a and b as integers. So we're given a point that is actually an x1, y1, and we're given m equals negative 3. That's our slope. And we're going to start with point-slope form. Y minus y1 equals m times x minus x1. Let's plug in all the information. Since y1 is 4, this is going to be y minus 4 equals m, which is negative 3, x, and then minus x1. x1 is positive 1, so minus 1. We're trying to make this look like ax plus by equals c. Let's look at how we can do that. And the first thing we want to do is get rid of these parentheses. So I'm going to distribute in this negative 3. Y minus 4 equals negative 3x plus 3. Now the next thing that I notice, I want ax and by to be on the same side. So I'm going to move this negative 3x over to the other side by adding 3x. So far I've got a positive 3x, a positive y, a minus 4 equals 3. Since I want it to be ax plus by equals c, I only want x's and y's on the left side. So we add 4, 3x plus y equals 7. Now it's a number times x plus there's really an invisible 1 in front of y equals 7. This is the form that we're looking for. Okay, in this case, we're trying to do the same thing, but we're given a different slope and a different point. So again, remember, this is our x1 and our y1. So writing out our form, y minus y1 equals m times x minus x1. Let's plug in what we have. This would be y minus negative 1 equals negative 5 over 3 times x minus x1 is 4. The next thing I note, okay, that's y plus 1. If you minus a negative, that's really the same thing as adding. Equals. I can distribute this negative 5 over 3. Negative 5 over 3x. And then a negative times a negative is a positive. 5 times 4 is 20. So positive 20 over 3. Now notice how I'm dividing these by 3 and it says I want integers. Fractions are not integers. Integers are numbers that do not include fractions. So we need to get rid of those fractions. The way you get rid of the fraction is by multiplying by whatever you're dividing by. So we're dividing by 3. I'm going to multiply everything by 3 on both sides. If I distribute that in here, that's 3y plus 3. And if I distribute it here, all it does is get rid of the fraction. Negative 5x plus 20. Okay? Now, I need to somehow make this look like ax plus by equals c. So I'm going to move this 5x over here by adding it. Five x plus 3y plus 3 equals 20. The last thing I need to do is just get the x's and y's by themselves on the left side. So we're going to minus 3. 5x plus 3y equals 17. And now we have a number times x plus a number times y equals 17, and they are all integers. So just be careful. If you want to get rid of that fraction, you need to multiply both sides by whatever that fraction, the denominator, is. Okay, now we're given 2 points, and we want to find the equation of the line in slope-intercept form. So we're trying to write some y equals mx plus b. We're actually going to use point-slope form to help us do that. Because we have points, let's call this x1, y1, and x2, y2. And we can use those points to write point-slope form. So to write point-slope form, the first thing we really need is the slope. We need m. So let's find m. M equals y2 minus y1 over x2 minus x1. So 5 minus 4 is 1, and 3 minus 0 is 3. That is m. Y minus y1 equals 1 over 3 times x minus x1. Then we take our x1 and y1 and we plug it in for x1 and y1 in the point slope form. Y minus y1 is 4 equals 1 over 3 times x minus x1, which is 0. So 1 over 3 times x minus 0. Now I'm trying to make it look like this. Y equals mx plus b because I'm asked for slope-intercept form. So the first thing I'm going to do is distribute 1 over 3 in. Y minus 4 equals 1 over 3x, and then 1/3 times 0 is just 0 still. Now since I just want it to be y equals, I'm going to add 4 to make y all by itself. So y equals 1 over 3x plus 4. And now I have slope-intercept form for that line. Alright, we're going to do another example so that you can see that one more time. Let's say we want y equals mx plus b. That's our slope-intercept form. We're going to use point-slope form and try and turn it into that. So the first thing we need is the slope. We need to figure out what is m. M is y2 minus y1. So 2 minus negative 4 over x2 minus x1. So that's 2 minus negative 4. It's really the same thing as 2 plus 4 is 6. And negative 4 minus 4 is negative 8. I'm going to reduce and simplify that. I can divide both those by 2, and knowing it's negative, because a positive divided by a negative is negative, dividing both those by 2 gives me negative 3 over 4. So that's my slope. So far I have y minus y1 equals negative 3 over 4 x minus x1. This point here is our x1 and our y1, so I'm going to plug that in. Y, and if I were to plug in negative 4, that'd be minus negative 4, and hopefully by now we've recognized that's really going to be a plus 4 equals negative 3 over 4 x, and if I plug in a positive 4, that's x minus 4. Similar to last time, we're going to distribute this in. So far I've got y plus 4 equals negative 3 over 4x. A negative times a negative would be a positive. And then to multiply fractions, we multiply the numerator, divide the denominator. 3 times 4 is 12. Divided by 4 is 3. So negative 3/4 times negative 4 would give me positive 3. And then the last thing, I want just y by itself. I want to be y equals, so I'm going to subtract 4 over y equals negative 3 over 4x, and then positive 3 minus 4 would actually be a negative 1. And so there is slope-intercept form. The last thing I want to talk about is vertical lines and horizontal lines one more time. Remember, a vertical line is always going to be x equals a, meaning no matter what, the x coordinate won't change. So if I wanted to write a vertical line with the point negative 3, negative 2, the x value will not change. Negative 3 will never change. So the vertical line through the point negative 3, negative 2 would have the equation x equals negative 3. A horizontal line is a line where the y coordinate is always y equals some number. So if we wanted to write a horizontal line with the point 1, negative 4, negative 4 is the y coordinate. That will never change. So the horizontal line through the point 1, negative 4 is y equals negative 4.